All right, so this is problem 10.3.53, and they say there are 15 people to be distributed among 3 committees of 5 people each, and we want to know how many ways can this be done. Okay, so you have 15, and you're going into groups of 5. So first of all, when you're choosing a committee like this and you're not assigning titles or anything like that, the order is unimportant, and so we're talking about a combination versus a permutation. So what I'm going to do is I'm going to start with the 15 people, and I'm going to take a combination of 15 people taken 5 at a time. What this represents is choosing 5 people out of the 15 to assign to the first committee. Okay. Once I've done that, those 5 people are on a committee, and you now have 10 people left to choose from. You can take from those 10 people another 5 and assign them to a committee, and then you're down to 5 people, and you will assign those 5 people to one committee. But now, in the process of doing this, the way that I have looked at doing this problem of assigning these groups right here, I've actually assigned them with some ordering. Because I took out of the 15, I took 5 and I put them in a group, and for instance, we could call that group A. So in the process of counting it this way, I've actually ordered these groups, but these groups are identical because they're all groups of 5, and so we actually have to divide by 3 factorial because we have 3 objects that are indistinguishable, and those 3 objects are the 3 groups of 5 people. Okay, so this 3 factorial here, if the groups had been of different sizes, a group of 5, a group of 4, a group of 6, for instance, then we wouldn't need this 3 factorial. The reason that's there is these groups of 5 are indistinguishable. A group of 5 is just a group of 5, and so they're actually the same thing, and in the process of counting this way, I put ordering into it that doesn't need to be there because they're indistinguishable. So we have to divide by the 3 factorial to take that unwanted ordering out, and that will give us our answer. So if we do these calculations, a combination of 15 taken 5, that's 3003 if you do that either on your calculator or by longhand. And remember that the combination formula is n factorial over r factorial times n minus r factorial. So if you were to just calculate that, then then you'll come up with a 3003 for this combination, and the combination of 10 taken 5 at a time is 252, and a combination of 5 taken 5 is 1. Okay, so I would multiply all of those together in the top. 3 factorial in the bottom is just 3 times 2 times 1. Okay, so multiply this, divide by 6 essentially, and you're going to end up with 126,126 ways that can be done. Okay, so that would be your answer right there.